Okay, so my talk is about proximity beacons. Let's see here. Okay, so I'll be switching back and forth between the presentation and demonstration. I'm not sure if this is going to work right if I do that. Yeah. Okay. Okay, so my name is Zaib, Kaleem. I'm with Access Agility. We're a VAR out of the Washington, D.C. area. We mainly focus on federal government customers in the US and then some commercial work also. In addition to the VAR work that we do, we also make some apps for iOS, macOS that you may be familiar with, but that's sort of a side project that turned into a product that we offer to the public. You can also find me on Twitter at WLNBook. I'm a part of the team follow back, so if you follow me, I'll follow you back most likely, and we can chat with each other. In this presentation, I have a link to some of the apps that I use for the demo part of it. So if you want to follow along and download the apps, there's a Dropbox shortcut link at bit.ly/beacon101. If anybody wants to download, they're mainly macOS and iOS apps. So if you have a Mac or iOS device, go to that website, download the one page, and then download those apps and follow along if you want in this presentation. So we're going to talk about proximity beacons. It's a 10 talk, so I'm not going to get into the technology. I'm not actually that familiar with the technology in terms of all the technical specifications, but we'll get into sort of what they are. Then we'll talk about hardware beacons and software beacons, get into maybe how to manage beacons and set them up, and then go over a design, and then talk about how distance is calculated. I mean, I think all of us are familiar with why we're using beacons, and I'm going to go over how distance is calculated with iBeacons. And then also try to end it with why Wi-Fi engineers should care about beacons, or what we can do to help out beacon projects and get involved in beacon projects. Proximity beacons. So the key part is that proximity beacons are Bluetooth low energy or Bluetooth beacons that advertise a message about their ID and then some other information to help applications, help management systems figure out where that device is located. And the proximity part is from the distance calculation that can be done with beacons compared to maybe GPS, which is more of a location technology, not a proximity technology, or Wi-Fi positioning, which is more focused on positioning versus proximity in most cases. Beacons, for privacy, they're considered to be more private compared to Wi-Fi, using Wi-Fi signals, because you're not actually tracking the user's MAC address. The beacon is transmitting a signal, and that signal is a one-way communication, and the user is actually not transmitting anything back about themselves, back to the network or to the beacon. Regarding security of beacons, it's sort of like the Wi-Fi, open Wi-Fi world or web world a long time ago. It's clear text. There's really no special security. You can spoof a beacon ID and do some tricky things. So if somebody wants to try some attacks out later on, I think Rick is probably going to help you out if he's here. Usage, the main usage for beacons today are indoor positioning or microlocation or tagging for valuables like wallets or user devices that they want to find. And the last item, iBeacon, I want to make sure everyone knows the difference between a proximity beacon and iBeacon. Apple comes out with their own rules or their own specifications for almost everything, and iBeacon is their specifications for Bluetooth Low Energy. They dictate what the advertisement should look like and what it can and cannot contain. And if you follow their specifications, you get to put the iBeacon logo on your product or your software, pretty much your hardware products and your software products. Hardware beacons, there are many of them. We're familiar with what Wi-Fi chipsets are. And if you look at a Wi-Fi chipset or an AP reference design, the beacon world is very similar. There are about 4 vendors that make Bluetooth low energy or Bluetooth 4.0 chipsets, or 4 main ones. And different manufacturers or different companies take that reference design and then make their Bluetooth low energy or beacon products. And out of these products, I mean, all of them are pretty good. The one I'm going to use for my demo is the Radius Networks product. I think Chuck is here, and Aruba Networks has a product, and other people have products too. If you want to learn more about the different hardware types and the pros and cons, that link is really good, and it's about a 20 or 30 pager that goes over all the different types of hardware beacons. If you have a device that that has hardware that supports Bluetooth 4.0, then you can convert your device into a beacon also. So in my case, I have a MacBook Air that does support Bluetooth 4.0, and I also have an iPhone 5S that supports Bluetooth 4.0, and I can turn my phone or my MacBook into a beacon. And same thing with Windows and Android. I suspect that there's software out there to convert those devices into beacons also. The next set of the presentation will be focused on a demonstration. But before we get to the demonstration, I want to kind of focus on some applications that you can use for beacons. One of the ones that most people are familiar with is wayfinding, the 49ers app that helps you get to the certain section or to the bathrooms. Another one that a lot of people are familiar with all the Kickstarter campaigns are tags, how to find your keys, how to find your wallet, tag for your dog, tag for your kid, all this tagging type scenario. And that's a pretty good scenario too. But overall, everything is based on a low-powered device that is either transmitting a signal or is stationary and transmitting a signal, or is moving and something else is detecting that signal, like your iPhone or your application. And in my demonstration, I'm going to try to show an app that I call a reminder app or a healthcare app, where we try to alert a user when they're near a water cooler and tell them to drink more water. That's a very simple idea. I'm not actually going to develop the app, but show you how it's very simple to take the concept of alerts and proximity and use an existing Bluetooth detector to create an app that would alert somebody like that. As a part of my design for this app, I have a Bluetooth beacon by Radius Networks. I have come up with a fictitious location ID for it, or a UUID that is not really mine or our ID, but it's 111 all the way down to that number you see there. I've got two beacons. One's plugged into my laptop up here, so it's really close to me. I have another beacon that is connected to this USB power battery adapter thingy, and that one is major 1, which is we're in Hyatt Hotel, so that's my major number. The UIDs are organization name or our location ID name. And then minor 2 is the one that I have on stage with my laptop. So in this demo, we have two beacons. One is up on the stage, and one is plugged into this battery power adapter. And then what you would do is, based on your application, based on the number of beacons, you would decide where to install them. So this is very similar to what we do for APs. You come up with a naming scheme where they'll be installed, and then you go around and actually install the devices. The next step is using tools out there to help you configure, troubleshoot, validate, perform diagnostics on the beacon. I'm not affiliated with Radius Networks or think they're the best or anything, but it just happens that when I first started researching beacons or proximity technologies, I happened to find their product, and I'm using their product for this demonstration. So they have multiple apps you can use. One is called Rad Beacon. That allows you to configure the beacon and use it for the settings that you want to set. Most manufacturers that make a beacon hardware product have their own utility to configure it, and they may have different ways of, with different features. Some may allow you to set a pin, some may use some other technology to secure the configuration. And in my case, the Rad Beacon is really easy to use because you can use a pin number to configure and secure the configuration. Scan Beacon is a $10 app they make for detecting beacons. So if you can remember what NetStumbler looked like 10, 15 years ago, the world of beacon scanning is sort of like that, very basic. It finds the UUID, finds the major minor, and sort of like that. So we'll kind of get into this in the next demo. And there are other two apps also, but the key part is that I'm using a lot of Radius Network apps, but there are other apps out there too. So we're going to switch over to demo mode here. Let's see if this works. Okay. So I've got my iPhone 5S. It's connected to the screen there, and I'm going to launch a few apps here to show you what it looks like. So I'll launch the Mac Beacon, which can turn my MacBook into a beacon. I'll launch a Scan Beacon, which is a scanner. So start that. And close that, start it again. Start that. It should be detecting some beacons, I hope. Okay, then I'll launch something called RAD beacon, which is the config utility from this manufacturer, but again, every manufacturer has their own utility and sort of what it can do. So we talked about the design of my network or my proximity network. I have 2 beacons. Each beacon has a UUID that I've configured, 111 all the way to 2. And then I designate where the beacon is going to be installed based on the major and minor. You can take major and minor and come up with any naming scheme you want to. To keep it simple for my demo, I use major 1, and then minor I change from 1 to 2. So in my case here, I name my beacon for the alert area for drinking water, drink 8 glasses of H2O. Here's the UUID. The major is 1, the minor is 1, and the power is -99. This power is not, at least in this config utility, this power is not the power being transmitted. This is what they call the calibration power, and it's pretty tricky how this works, but the way locationing works in the beacon world is that at least the iBeacon world, Apple says that you need to calibrate the distance from the beacon 1 meter away, and you don't take the cover off the 5S or the 5, 1 meter away, move the phone up and down for 10 seconds, and then that will calibrate the distance of the power 1 meter away from the beacon, and then that value is transmitted with the beacon to the actual receiver, the application or the phone. So knowing the received power, the RSSI, and the reference transmitted power 1 meter away from the iBeacon, it does a path loss calculation in iOS, and it does some magic, loss factor calculation to determine how far you are from the beacon. So we'll do a quick test to see if this really works. So I've got my beacon right now up here. Let me open up my app here, go to locate beacon. So imagine I have an app called Drink Your Water, and it detects this here, right? Oops. Okay, so I've got, what I did was, every app is probably different how it does it, but in this app here, you go locate beacons, you go to the Drink Your Water iBeacon, and you calibrate it. So I'm supposed to stand 1 meter away from that beacon, so about 1 meter away. Don't put my hand on the top. Click calibrate, move it up and down, and then use my legs. Whew. Come on, start. Come on. Calibrate. Calibrate. There you go. Come on. It's coming. There you go. There we go. Okay. So this app now using the Apple iBeacon specification, which has some other mathematical logic behind it, says that to calibrate this beacon with this utility, I have to enter -90 as my transmit power 1 meter away from this beacon, so that when it transmits that -90 in its beacon message, that's the reference power it uses for determining distance. Figure that out, right? So I go back to my Drink My Water iBeacon. I put -90 in there. So that's my calibration value. I've got the power you set doesn't matter, right? So if you want to keep your beacon area small, use low power. If you want to make your beacon area big, use high power, but the calibration value dictates how it does the calculation. So for example, if I have a lot of beacons, but I want to know am I standing on this side of the stage versus that side of the stage, I could have a low power beacon on this side and a low power beacon on that side, but then use the calibration power to determine the location. So I apply this, put my PIN number. Hopefully it should change it, I hope. Come on. Uh-oh. See, it hasn't changed it because it says the reference power is 99. It should be 90. So let's see what happened. So, start. Yeah. there may be something with some of these beacons, like it won't actually trigger the config until you reboot. If you've ever used like some other gimbal beacons, that's like sort of when they get into the config mode.
Well, it looks like the demo gremlins got you.
Come on. Okay, it's not that critical to get the exact calibration, but you saw how the phone does the calibration. I calibrated it before the demo, so it kind of has information about the transmitted power. So right now, my number 1 beacon, I'm sorry, still at 99 as my calibration number. So that's not that critical right now. But to show you sort of how you validate your calibration is you go to distance. Okay, let's see if it finds it. No. I'm sorry, maybe no. Come on. There we go. So now it's saying it's, what is that, 30 centimeters away. It's probably, would be slightly different depending on where I am, but that's about, pretty good. It's not bad. If you turn around. The phone? No, you, not 180. Me? You and the phone. And the phone, okay. Should I do the... But the key is that their calculation for distance is based on some type of free space loss and some loss factor. So we know that all this math really doesn't mean anything, because what if I have the phone between me and the beacon? It should change, right? Let's see if it changes that. Yeah. Anyway, so it should pick it up. I'm not sure why the software is not picking up the distance that fast, but usually it's pretty good about detecting. Right, so the key is that you can use a tool, the config tool out there, to figure out your distance and what's going on. If somebody wants to take this beacon and hold it or walk away from the stage, it should change it also, and I don't have to walk around. Anyone?
I think we're done. Yeah. This was a fantastic 20 talk.
Yep, there you go. Thank you.